Bismillah ar-Rahman ar-Rahim. Assalamu alaikum, dear students. Welcome to the second online class of computer architecture. The topic of today's discussion is registers and its classification. Okay, so first of all, we will see what are registers, what role do they play, and what are the major characteristics of registers. Think of the CPU as a person working at a desk. एक सिनारियो आप कंसिडर करें कि there is a person working at a desk और उस person को हमने CPU कंसिडर करना है. Now, if that person has to go to a cupboard every time they need something, the work becomes slow. अगर बार बार उसको cupboard जाना पड़ेगा तो काम बहुत slow हो जाएगा. So instead they keep important items on the table ताकि वो easily table पे उसको रख भी सकें उन चीजों को और वहां से उन टेबल से उन चीजों को पिक भी कर सकें. So now that table is like a register. Okay, so a processor register is a very fast computer memory used to speed up the execution of computer programs by providing quick access to commonly used data values. A register is a very small but extremely fast memory inside the processor. It is actually the fastest memory in the entire computer system, as we have already discussed. और जैसे यहाँ पे second point पे भी लिखा हुआ है कि these registers are at the top of the memory hierarchy and are the fastest way for the system to manipulate data. So whenever the CPU needs to perform an operation, it prefers to use registers instead of RAM because registers provide immediate access. If that thing is not found in the registers, then according to the memory hierarchy, it is searched in the cache, and even if it is not found in the cache, it is then searched in the random access memory. Now, the third point, this is another important thing to consider, which is the size of the register. When we say an 8-bit or 32-bit register, iska matlab kya hai? We are simply talking about how much data it can hold at one time. I repeat, the size of the data shows that how much data it can hold at one time. So obviously, like 32-bit is more than 8-bit, so larger registers can hold more data, which improves processing capability. Let's move forward towards the classification of the registers. Okay, so we categorize the registers into three categories: the accumulator, the GPRs, general purpose registers, and the SPR, special purpose registers. First of all, we have the accumulator, AC. इसको short form में AC कहा जाता है. This is one of the most frequently used registers. So whenever इसकी responsibility देख लें, whenever data is fetched from the memory and we want to perform the calculations, the accumulator is often involved. You can think of it as the CPU's main working registers for arithmetic operations. Whenever we have to perform arithmetic operations, तो सबसे जो अहम role play करता है, that is the AC register, that is the accumulator register. Then we have the GPRs, the general purpose registers. These are more flexible. जैसे कि नाम से जाहिर है ना, they are general purpose, they are more flexible. They are used to store temporary data, intermediate results, and values during execution. By during execution we mean जब arithmetic operations perform हो रहे होते हैं, arithmetic and logical operations, तो उस दौरान we use GPRs as per the requirement. But when I say we use, so it means the processor uses them or the CPU uses them. So as programmers we can directly use these registers in assembly language. जैसे कल हमने in the discussion of CISC and RISC में कुछ examples ऐसी थी जिसमें registers को हम use कर रहे थे for storing the temporary data or for holding the intermediate results. So if the accumulator is like a specialist, general purpose registers are like multi-skilled workers. ठीक है, multi-skilled workers which can perform multiple tasks, which can be used to perform multiple tasks. और जो third category है हमारे पास, that is special purpose registers. Now let's talk about them. These registers are not directly controlled by the programmer. Why? Because they are not general purpose. They have a specific task. They are special purpose. So instead they are used internally by the CPU to manage the execution of instruction. आगे जाकर आपको कुछ examples बताई जाएंगी in which we will discuss some important special purpose registers. You can think of them as the management system of the CPU because they have a specific task to perform while the instructions are being executed. They ensure everything runs smoothly behind the scene while the program is getting executed. So now let us understand some key special purpose registers. First of all, we have the MAR, the memory address register. So whenever the CPU wants to access data from memory, it needs to specify the address, और वो address कहाँ पे store होता है? That address is stored in MAR, right? Whenever the CPU has to fetch some data or instruction from the memory, so the address of that instruction is stored in the memory address registers. The second one is the memory buffer register. Once the data is fetched from memory, जब data हमारा आ जाता है, it doesn't go directly into processor. Okay, it first comes into MBR, memory buffer register. So this register temporarily holds the data being transferred, right? Next is the instruction register, IR. So this is very important because it contains the instruction that is currently being executed. As we know that at any given moment, if the CPU is executing an instruction, that has to be present with the CPU. So that instruction which is being currently executed is stored in IR, instruction register. And finally, as we have discussed in the previous class as well, we have the program counter, PC. This is very important. It always holds the address of the next instruction to be executed. So after one instruction is completed, the PC automatically moves to the next one. So the CPU, with the help of the program counter, always knows what to do next because of the PC, क्योंकि PC में next instruction का address होता है. EIP, Extended Instruction Register. Now EIP, as we will be discussing in the upcoming class, is not a general purpose register like EAX or EBX, for example in x86 architecture. Now in x86 architecture we have this register called EIP, which stands for, as I have already mentioned, Extended Instruction Pointer. This register is very similar to the program counter. Its job is to store the address of the next instruction. But here is a key point, as I have already mentioned, that it is not a general purpose register. You cannot use it freely like other general purpose register, GPRs. It has a very specific responsibility, which is guiding the CPU during execution. So let me give you a real life analogy, as I always do. If you imagine the CPU as a traveler, EIP, Extended Instruction Pointer, is like a GPS telling it where to go next. And it is mostly used in x86 architecture. Talking about the GPRs, general purpose register, now let's talk about them in detail. In a typical CPU, especially in x86 architecture, we have registers like EAX, EDX, ECX, ESI, ETI, EBP, ESP, and EBX. Although they are called general purpose in practice, but each of them has a preferred role. This design helps improve efficiency. Now, I'm not saying they have a specific role and they cannot do anything else. I'm using the word they have a preferred role, and वो मैं भी आपको बताता हूँ कि वो क्या role है. So they are general but not completely random in their use. That is the point I'm trying to explain. They are general but not completely random. और वो अभी आपको upcoming slides में इस चीज का idea हो जाएगा. So we have the EAX register. Let's start with the EAX. Now this one is one of the most important registers. It is mainly used for calculations and also stores return values from functions. Now you can see they are not completely random, which I was explaining in the previous class. Yes, they are general purpose as they can be used for calculation and for the storage of return values. Many arithmetic operations are optimized to use EAX, and in some cases, like multiplication and division, its use is mandatory. So, as I have mentioned in the previous class, they are general purpose, but they are not random registers. They have a preferred role, और वो preferred role आपको अभी बता दिए. Then we have the EDX. EDX works closely with EAX. ठीक है, जैसे यहाँ पर mention है कि it is basically an extension of EAX. Extension का मतलब कि ये उसके साथ मिलकर it provides you with additional capability. Now EDX works closely with EAX when operation becomes complex and more data is needed. EDX support EAX by holding additional data. So you can think of EAX as the main worker and EDX as its assistant. जब भी main worker को help की जरूरत होती है तो वो EDX को request करता है या उससे मदद लेता है. Then we have ECX. Now ECX is also known as the count register or counter register. तो count की जरूरत हमें पड़ती है mainly in loops. It is mainly used in loops whenever we repeat an operation multiple times, just like normally it happens in the loops. So ECX keeps track of how many times it should run. So now class, you have already studied loops in different programming languages. So now today you have come to know that at the back end in the CPU, it's the ECX register that basically keeps account of the iterations that we are performing using loops. Then we have the ESI and EDI registers. Now ESI stands for source index. So, and EDI stands for destination index. So the source index points to the location of input data, जहाँ से data pick किया जा रहा है या आ रहा है, and EDI stands for destination index, and it points to where the result should go. So just think like an array. ठीक है कि एक array से आप data pick करके और new array में store कर रहे हैं, maybe after performing some processing. So whenever data is being moved or processed in sequences, these registers, this ESI and EDI, play a key role. Then we have the ESP and EBP registers. Now, first of all, please note that dono ESP and EBP are stack related registers. ESP is the stack pointer, SP, stack pointer. It always points to the top of the stack. You have already studied the details of the stack data structure and its importance in computer memory and the internal working of the computer in your data structure course. So ESP is the stack pointer. It always points to the top of the stack, while EBP is the base pointer, which points to the base of the stack. And whenever a function is called, its parameters and return addresses are stored in the stack. So that's where the ESP and EBP play a very significant role, because ESP and EBP helps manage this entire process. So they are essential for function calls and maintaining program flow. Then we have the EBX register. Now, unlike the other registers which have the preferred role, EBX does not have any preferred role. It is mostly used as an extra storage register. So because of this flexibility, programmers often use EBX when they need additional space to store data. So this was about the general purpose registers. Now we come towards another important aspect of the discussion related to registers, and that is issues with general purpose register. Because as a computer architect, you need to understand what are the possible things or what are the possible issues that you are going to be facing when you will be working as a computer architect. So now let's discuss some important design issues. One of the key issues is the decision whether to use completely general purpose register or specialize their use. So the first issue is that in registers को, we are talking about the general purpose registers. The first issue is whether registers should be fully general purpose or specialized. अब यहाँ क्या है कि if they are more general, programmers get the flexibility. ये याद रखें, from the programmer's point of view, If they are more general, programmers get the flexibility, but if they are specialized, performance can improve. तो एक ट्रेड ऑफ है, और यहाँ पे ये discussion है कि by making them more general purpose, the programmer flexibility increases as the programmers don't have to specify the OP code. क्योंकि जब रजिस्टर जनरल पर्पस होगा तो फिर उसके अंदर जो इंस्ट्रक्शन है, इंस्ट्रक्शन में हमें ओपी कोड जो है वो डालना नहीं पड़ेगा. That to what type of register a certain operand specifier refers to. The second issue, so I hope you understood the trade-off. कि एक तरफ if we go towards making them more general purpose, so it's good for programmers. But if we try to specialize them, if we try to like give them a preferred role, so performance improve hogi. So that was the first issue. The second issue is the complexity. Making registers more general increases the complexity of control signal. Now देखें बहुत important point आ गया. So जब आप register को ज़्यादा general बनाएंगे, जैसे हमने पीछे discuss किया है, तो complexity of the control signal एक तो वो ज़्यादा होगी, it increases the complexity of the control signal, and instruction formats which can actually reduce performance. So that's what written here. Another issue is that by making a register more general purpose, its functionality will increase. क्योंकि वो जनरल है, आप मुख्तलिफ काम परफॉर्म कर सकता है, and thus more control signals will be required to control its operations. And the instruction length will also increase, hence the overall performance will decrease. तो जब control management ज़्यादा होगी, आपकी instruction का size ज़्यादा होगा, so ultimately आपकी performance decrease होगी. ठीक है? So, यहाँ पे एक चीज आप ये ध्यान में रख लें कि ना आपको ये रिकमेंड किया जा रहा है कि आप इनको ज्यादा जनरल पर्पस बनाएं, ना आपको कहा जा रहा है कि आप इनको स्पेशल पर्पस बनाएं. आपके सामने इशू रखे जा रहे हैं, ट्रेड ऑफ्स रखे जा रहे हैं. इट्स एन एज एन आर्किटेक्ट नाउ इट्स योर रिस्पांसिबिलिटी टू डिसाइड कि आपने क्या करना है. देन we have other issues. One of them is the number of general purpose registers. So another, if we have too fewer registers, like अगर registers की तादाद बहुत कम होगी, the CPU has to access memory more often, which slow the things down. But simply increasing the register doesn't guarantee better performance either. And now this is again a very important point. कि अगर आपने GPRs की तादाद कम रखी है, तो एक चीज तो गारंटी है कि क्योंकि जनरल पर्पस रजिस्टर्स कम हैं, सो कम डाटा स्टोर हो सकता है इनके अंदर. सो द CPU would be accessing the your primary memory or the memory, simply the RAM, again and again. लेकिन on the other hand, just by increasing GPR, we cannot guarantee as an architect that the memory reference will decrease. So maybe कि GPRs को बढ़ाने के बावजूद भी आपके जो memory references हैं वो ज़्यादा रहे. And finally, we have the issue of size. And this is the last slide regarding the issues with GPRs. We have the issue of size. Address register must be large enough to store full memory address, while data registers must handle data of different types. इसी वजह से some systems even allow combining registers for larger operations. क्योंकि अगर आपका रजिस्टर का साइज इतना नहीं है कि वो एक कंप्लीट डाटा आइटम या कंप्लीट एड्रेस को स्टोर कर सके, फिर आपको मल्टीपल रजिस्टर्स को इकट्ठा करके वो काम करवाना होगा. So for that purpose, in the next slide, we have an example register organization. Let's talk about a sample processor, that is 8086 processor architecture. We have 4 registers over here, AX, BX, CX, and DX, and they are 16-bit registers. In the 80386 processor, these are extended to 32-bit and renamed as EAX, EBX, ECX, and EDX. So these are just naming conventions. Now, here is a very interesting design decisions. The 32-bit registers are divided into two 16-bit parts. जैसे आपको बता रहे हैं ना, 80386 में the EAX, EBX, ECX, and EDX, all of which are 32-bit registers. So as a architect, as a designer, they have decided to divide it into two parts, left and right, each of 16 bits. As you can see over here, AX, BX, CX and DX दोनों को 16 बिट each में लेफ्ट एंड राइट पार्ट में डिवाइड कर दिया गया है. Now, why was this done? This is a very important thing you should note. Why was this done? Because older programs written for 80886 should still run on 80386. This is called backward compatibility class. Very important. The backward compatibility. जो डिजाइनर्स ऑफ 80386 थे वो चाहते थे कि जो एप्लीकेशन 8086 के लिए बनाई गई हैं दे मस्ट बी एबल टू रन ऑन 80386. वहां पर हमारे रजिस्टर का साइज 16 बिट था. 80386 में रजिस्टर का साइज 32 बिट हो गया. So they have divided into two different left and right sides of 16 bit each. So now what happens at the same time, programmers can choose whether to use full 32 bit registers or just part of them depending upon their need. तो आप complete 32 bit registers को भी use कर सकते हैं as a programmer, और अगर चाहें तो एक AX के for example 16 bit right part और 16 bit left part को भी आप use कर सकते हैं, right? So as it is written, this was done in order to allow the applications of 8086 to run on 80386 architecture, जैसे मैंने आपको पीछे बता दिया, and it allows the programmer to use the register according to the requirements, either full or partial, as I have just mentioned. So overall, registers are the heart of CPU operations. Let me conclude. They are the heart of CPU operations. They make execution fast, efficient, and organized. Understanding how different registers work gives you a clear picture of how programs are actually executed at the hardware level. Thank you very much. I hope it's clear. If you have any question, you are more than welcome to ask. Thank you. Allah Hafiz.